Hello everyone, my name is Ali, the Bazooka Prophet, and today we'll be working on a very interesting video which is useful in the field of biochemistry and also in the field of chemistry. And that topic is called the thin layer chromatography. Now do not forget that in our previous video we talked about chromatography as a concept, talking about how the component of mixtures can be separated between two phases. Now the two phases include the mobile phase and the stationary phase. Now, and we said that we have different types of chromatography which are classified under three headings. And one of the types of chromatography is what we are about to discuss today, which is called the thin layer chromatography. Now, first of all, what is a thin layer chromatography? You should get that concept clear. Because the truth is we can't just jump into issues without first of all knowing what it's all about. Now, do not forget that the thin layer chromatography is used to isolate mixtures, and that mixtures are non-volatile mixtures. Do not forget non-volatile. We have two kinds of mixtures of substances which are volatile and non-volatile. Now, when we say something is volatile, it means it is readily turned into the gaseous phase, while the opposite is for non-volatile. They do not readily turn into the gaseous state. An example of non-volatile liquid is glycerin, having the molecular formula of C3H8O3, while in the case of non-volatile solid, we have sodium chloride, which is popularly called common salt. We have not only sodium chloride, we have sugar. So we continue. Now, again, too, we should also understand that the thin layer chromatography is used in the identification of substances and also testing for the purity of substances of a compound. And do not forget that compounds can be pure or impure. Now, when a substances or when we say that a substance is pure, it means it should be able to leave one spot. Meaning it should be just one spot. But in the case of impure, different spots or two or three or four spots are identified. And with the use of the thin layer chromatography, we can be able to know, we can be able to differentiate between pure and impure substances. Please do not forget that the thin layer chromatography helps in the determination of what now the components in the mixture. Now we quickly run down to the phases that are involved in thin layer chromatography. Talking about the mobile phase, talking about the stationary phase. Now in the mobile phase, do not forget, a developing liquid, do not forget, a developing liquid which travels up the stationary phase. This can only be possible by the action, or we call it the capillary action, the upward rise or the upward movement or the rise, carrying the samples with it. Please do not forget. But in the case of the stationary phase, it involves what now? A thin layer of adsorbent, and usually we make it of silicon gel or aluminum, or lastly the cellulose. Though they can be more, but basically these are the most common ones. Now the thin layer chromatography involves three steps, as you can see right on the board. But we have been able to give a summary of this point so that to make it easier for you to also jump down while you are studying this video clip. Now we have three steps that are involved in the thin layer chromatography. Number one, we have the spouting step. Number two, the development step. Number three, which is lastly the visualization step. Now in the case of the spouting step, simple. A micropipette is used to take little of this sample, and when that is done, what happens next? The solvent sample evaporates and leave a spot. And we'll move to what now? The next step, which is what now? A development step. Now, in the case of the development step, from the word development, now these mixtures are what now? They develop, and as they develop, what happen with the use of these processes, or with the use of this capillary action, which we have said that a developing liquid which travels up the stationary phase carrying the samples with it. So that step, or that process is, or that step is what we call what now? The developmental step. But in the case of the visualization step, very, very simple. From the word visual, what you can see. Now, it is easier to be able to identify substances that are colored. But in the case of thin layer chromatography, it is not always like that. So most times, these spots that are left in the chromatogram paper, or in the we call it plates in this case, what happens? We use a fluorescence bulb to identify them, and a pencil is used to circle those points. Now, it will help you to understand that the most common, the most common non-destructive visualization for TLC plates is what now? The ultraviolet light. Now, do not forget that when no spots are obvious, the plate is held under a UV lamp, and many organic compounds can be seen under this technique. Now, we move straight down. All right. So we talk basically right now what we call RF, which is called the retention factor. Now, what is a retention factor? Retention factor can be defined as the distance moved by the sample over the distance moved by the solvent front. Now, with the use of the retention factor, one can be able to pinpoint some basic points from it, and the points are: when your retention factor is equal to 1, it simply tells you that that substance, or the substances, are what now? Are very soluble in the liquid. But when the retention factor is close to 0, it shows that the substances are insoluble in the liquid. Look at the 2 steps, or the 2 points. When your ROF is equal to 1, that the substances are very soluble in what now? In the liquid. But when the retention factor is not close to 0, it shows that the substances are insoluble in the what now? In the liquid. Now, straightway, we talk about some basic points here. Now, what are the points? Now, the most effective way to identify a compound, please do not forget, is to spot for known substances. Is to spot for what now? For known substances. Please do not forget that under the thin layer chromatography, the thin layer chromatography is used to test for purity, and we've said under that purity to know whether a substance is pure or impure. So it means that if the thin layer chromatography should leave one spot, or if the process should leave one spot on the thin layer chromatographic plate, as you can see here, it means that it is pure. But if 2 or 3 spots are then identified, take note, it means it is impure. And we have said that the most effective way to identify a compound is to spot for what now? For known substances. And lastly, that the liquid or element, take note, the liquid or element is the what now? Is the mobile phase, and it slowly rises up the thin layer plate by capillary action, which we have said previously. Now, this is a schematic diagram of the thin layer chromatography, talking about this place here, is called the thin layer chromatographic plate. This is the beaker. You can either call it the beaker or the chamber, the thin layer chamber. Now, you see this line here? This spot here, what we call the pencil line. And this point here is what we call the spot of mixture. While down here is where the solvent lies. Now, the three steps that are involved in thin layer chromatography, in our next video, we will take our time to go deep down on the spotting step, the development step, and lastly, the visualization step. So, although we talk briefly about it, but in our next video, we'll talk deep on it. This very time, say God bless you. Have a nice day. You are the best.